Okay, boys and girls, tonight's video is about area of combined rectangles, or complex shapes you may hear about them being called. Remember that the formula for area is length times the width. Could be written with the letters next to each other or separated by the multiplication sign. Means the same thing. Okay, so I have these rectangles here, and they're separate rectangles. My pink one and my orange one. They have one thing in common. They're both the same width, 12, but they have different both the same lengths, 12, but they have different widths, 9 and 4. So I'm going to figure out a separate area for each one. 4 times 12 is 48. And I told you I like to put the area on the inside. Okay. And then 9 times 12, I'll just figure that out right here. 18, 108. All right, so we have our separate areas. If we wanted to find out what the combined area was of these shapes, we would just add these two areas together. And so when we're given a complex shape or combined rectangles, it might look something like this. Same piece, I just told you to turn it over. Okay, same measurements are on it. I'm just going to spin this around this way. Doesn't really matter where they're connected. Could be down here. There's the same measurements. And so, this one here, we already know is the area of 48. And that's still 108. And combining the two would give us the total area. So it doesn't matter if they're separate or together. You have to look at them, even if there are one shape and there's no line, you would draw your imaginary line here and use the measurements given to figure out the separate areas in order to add those back together. Because you can't do a length times a width if this shape glued together does not have just one length and one width. So you'd have to envision a line across here, cutting it into two rectangles where you could use the formula. Now the other thing you could do with a shape like this is that you could imagine if the shape was whole, trying to make straight lines here, if this shape was whole all the way around, okay, and you would use your largest measurement numbers to figure out one solid rectangle, and then subtract this area here. So we would have to say, well, this is a 9 by not just 12, but 12 and 12, remember. So this is a 9 by 24 rectangle. And I'll scratch that out over here real quick. Okay, and so 9 times 24 is 216. That's for the entire solid rectangle. But remember, this piece is missing, so we have to figure out what this is. We have to figure out what this piece right here is. We know that across the top, at its biggest part, it's 9. And we know that if this is 4, then that means this is 4. And 9 minus 4 would give us 5. So this piece right here is 5. And then the width of this, or length of this, excuse me, is that same thing as this 12. So this is a 12 by 5 missing piece. And 12 times 5 is 60. So I'll subtract that from that 216. Okay, and so the area of this is 156. Let's double check by adding our partial areas that we got earlier. 108 and 48. I already like the way this is looking because I know that 8 plus 8 is 16, and that ends with a 6. 1 and 4 makes 5, and 1 and nothing makes 1. Yes. All right, so we could break it up into two separate rectangles, or we could, and then add together, or we could do one solid rectangle using its largest measurements and then figure out the missing area to subtract from. And that's how you do it. Make sure you practice your IXL codes. Tonight it's P22, focusing on what we had done in class today of finding the missing measurement number.